Hello, my name is Fatih Furkan Erkeç, and this is assignment 4. I will ask ChatGPT, can you give me a basic practice question on randomized algorithm? And the question, you are given an array of integers and you need to find the median of the array. Design a randomized algorithm to find the median with high probability in expected reward time. Think about using quick select algorithm, which is a randomized algorithm for finding the kth smallest or largest element in an unsorted list. You can adapt it to find the median. Feel free to ask for a solution or more hints if you'd like to work through this problem. Okay, I'm going to think about that and I will stop the video in here after I have something in my mind. I will continue. Okay, to implement the quick select algorithm, I take a look at the slides and to find the median of the array, the integers with high probability in expected linear time, we can adapt the quick select algorithm. And quick select is a randomized algorithm, as we know, and quick select used to find the kth smallest or largest element in an unsorted array, unsorted list, and it can be modified to find the median, and we will try to do this. And we will do this by choosing a random element from the array as the pivot element. After that, we partition the array into 3 parts. One is elements for less than the pivot, and one is elements equal to the pivot if there are duplicate elements, and one is elements greater than the pivot. After that, we check the size of less than and equal to partitions. If the size of less than partition is greater or equal to n-1 over 2, I used n for size of the array. We know the median is in the less than partition. We recursively apply the algorithm to this partition, and if the size of the less than partition plus the size of equal to partition is greater than n-1 over 2, we know the median is the pivot element. Otherwise, the median is in the greater than part. Recursively, we apply the algorithm to this partition, but adjust the target index accordingly. And we continue this process recursively until we find the median. And I will try to implement this quick select algorithm in Python code. And I will try to implement. And I'll think about that for a bit. I will pause the video in here and I will continue after the I come up with an idea. Okay, we define a function find underscore median takes array, and we create an and this equals the length of the array. Then if n mod 2 equals 1, if the array size is odd, we return the element at the middle in text, so return as a quick select. We'll define it. Quick select. Let's define the quick select in here for now. Define quick select and array left, right, and k. Smallest. And this will turn array 0 and -1 and over 2, and else if the array size is even, we will return the average of the two middle elements. So we will define mid1 and mid2. This mid1 is quick select array 0 and -1, and mid2 equals to quick select array 0 and -1 and over 2 -1, and return the average of these values, mid1 plus mid2 over 2, and I will check the quick select algorithm, and I will try to implement it. I will stop the video for now, and I will continue after some quick look at the algorithm. Okay, let's write quick select. If left go to right, then return array left, and let's define pivot index is random randoms left and right. We will take random pivots from this, and pivot underscore index is partition. We'll define partition. Let's array lefts, rights, and pivot index. Okay. If k equals to pivot index, then we will return array k. And we will make a mistake in here too. Okay. Let's do these two. If pivot index is equal to k and k is equal to pivot index, we return kth element of the array. Else if k k is smaller than pivot index, then we will return quick select array lefts, rights, pivot index. Oh, k. Looking for k. And these, and finally else. Return quick selects array pivot index +1 rights and k. Okay, we can define partition now. Partition in the partition we will define this function takes array lefts, array lefts, rights, and pivot index. Now we'll define pivots value equals array pivot index and array pivot index array rights lefts equals array lefts and okay, let's make array pivot index pivots index stay here store actually I think I made a mistake here. I couldn't remember how I implement this. I will check it real quick, and after that we will continue to write it. Okay, I write partition function, and here we swap pivot index and write to pivot index to the right and right to the pivot index, and we store the index left, and we have a loop in here for e in range left and right. If array I smaller than pivot value, we swap array I to array store index and array store index to array I, and after that we increase store index by 1, and after that we swap store index to right and right to store index, and after that we return the store index. And after we return store index to pivot index, we look if k equals to pivot index. If it and then we return array k else if k smaller than pivot index, we return quick select function again, and else we return quick select pivot index 1 and right and k for this for the if k is bigger than pivot index. And here are some test cases with expected values of them. For array expected values in test cases, results equals to find median array. If results equals to expected result, we print pass median of array is sorted array is results expected value, else we print fail median of array is results. The expected is this, and when we run the code, as we can see, it works just fine. In this array, our median is 5. In this, our median is 2. In this, our median is 20 plus 30 over to 25. And if you try like that, it says fail. The median of this array is 4.5. The expected 7.5. So we change it and it fails. If we make it 7.5, we rearrange the array to this expected value. So let's make it 4.5 and maybe we make it this 4 to 5 and 5. Yeah, it passes again. Okay, that's it for the basic question. Let's ask ChatGPT if that is correct. Is my answer correct? Can you check it without giving me answer if I have mistakes? Okay. Oh, this part. Let's fix that. We said not give the answer, but the ChatGPT gives the answer immediately. So yeah, it works fine. Nothing changed. Okay, that's it. I'll stop the recording in here. Now we will ask a basic practice question on analyzing runtime. randomized algorithm. And here is the question. I will think about that, and the video continue after that. I will pause now. And here is my answer. For each pair of elements in the list, we assume n distinct elements. There is a 1/2 probability of swapping them. There are n times n-1/2 pairs in a list of size of n. And the expected number of swaps for a single pair of elements is 1/2. Therefore, the expected numbers of swaps for all of the pairs is 1/2 times n-1/2, which simplifies to n/2 minus n/4. For 2, the expected running time scales quadratically with the input size n. As n increases, the number of pairs in the list also increases, and the expected number of swaps increases accordingly. This means that the expected running time is proportional to n squared in big O notation, that is O n squared. In 3, if we were analyze the worst case running time of this algorithm, it would be different from the expected running time. The worst case occurs when every pair of elements in the list swaps, resulting in n times n-1/2 swaps, which is proportional to n squared over 2, so n squared. The worst case running time is O n squared. Comparing the worst case running time to the expected running time, we can see that the worst case is a factor of 2 slower in terms of swaps. However, it's important to note that the worst case rarely occurs in practice because it would require an unlikely sequence of random swaps for every pair. So the expected running time gives a more typical performance estimates for the algorithm. Sorry for the interruption. Let's test our answer is true or not. Answer. Okay, our answers are correct and well explained. To recap, we correctly calculated the expected number of swaps for all pairs in the list, which is n/2 minus n/4. We accurately pointed out that the expected running time of the algorithm scales quadratically with the input size n, denoted as O n squared. Explained of the worst case running times accurate. The worst case occurs when all pairs are swapped, resulting in O n squared swaps, and correctly note that the worst case is unlikely in practice due to the random nature of the swaps. Overall, understanding and explanation of analysis of the running time for this randomized algorithm are correct. Great job. And that's it for randomized algorithm video. Thank you for watching.